All right, so today we're diving deep into something really, really fascinating. Liquid breathing.
Liquid breathing, yeah.
Urban liquid. Instead of air, I mean, it sounds like pure science fiction, right? But the science behind it, it's real. And it's kind of blowing my mind.
It is pretty wild. Essentially, what we're talking about is, taking the air out of our lungs and replacing with a special liquid, a liquid that's capable of carrying dissolved oxygen, just like air.
Okay, so hold on. What kind of liquid are we talking about here?
Well, these special liquids are called perfluorocarbons.
Perfluorocarbons.
Yeah,
Okay.
and they have this amazing ability to just absorb and hold huge amounts of oxygen. Think of it like a bottle of soda. You see all those bubbles? That's carbon dioxide dissolved in the liquid.
Right, right.
Perfluorocarbons, they work in a similar way, but with oxygen instead.
So are you saying, like, we could potentially fill our lungs with this stuff and breathe underwater like fish?
Well, not quite that simple, unfortunately.
Okay.
Perfluorocarbons, they can carry oxygen, that's true, but they're also much denser than air. Much, much denser.
Okay.
And that makes breathing them, well, quite a challenge for our lungs. Our lungs they're adapted to breathing light, airy gases,
Right.
not dense liquids.
So if it's so difficult to breathe, why are scientists even bothering with this? I mean, what's the big payoff?
Well, the potential benefits are actually pretty massive, especially when you start thinking about deep sea diving.
Deep sea diving. Okay.
Yeah. Imagine being able to dive to extreme depths, but without the need for all that bulky scuba gear and without the risks that come with decompression sickness.
Wow. Yeah, that would be incredible. That would open up a whole new world of underwater exploration.
Exactly. And it's not just exploration either. Liquid breathing, it could totally revolutionize underwater rescue operations.
Like hell.
Think about it, submarine accidents or other deep sea emergencies. Liquid breathing, that could be the key to saving lives in those situations.
Okay, so I'm starting to see the potential here. It's really amazing how something that sounds so, futuristic is actually being researched, as a real practical solution.
It is, and it doesn't stop there either. Liquid breathing, or to be more precise, liquid ventilation, is also showing incredible promise in the medical field.
Oh, interesting. How so?
One of the most promising areas is in treating lung conditions. Premature babies, for example, they often have underdeveloped lungs, which makes it really difficult for them to breathe air effectively. But liquid ventilation, that can help distribute oxygen evenly throughout their tiny lungs.
So the liquid kind of acts like a temporary support system until their lungs are strong enough to breathe on their own.
Exactly. And it's not just for babies. Liquid ventilation is also being used to treat adults with various lung injuries and diseases. It acts as a sort of protective cocoon, reducing inflammation and promoting healing.
So it's like giving the lungs a nice, soothing oxygen bath.
Yeah, kind of. It's a pretty remarkable concept. And you know what's funny? This whole concept of breathing liquid isn't new to us. I mean, it's been featured in a Hollywood movie decades ago.
You're talking about The Abyss.
Exactly.
I remember that scene. The diver goes into that liquid-filled chamber. I thought it was just, pure science fiction back then.
I know, right? But while the movie obviously dramatized it for entertainment, it did kind of introduce this idea of liquid breathing to a wider audience. And now, years later, it's gone from the big screen to actual scientific research.
It's amazing how something that once seemed like, pure fantasy is now becoming a reality. Makes you wonder what other seemingly impossible things might be within our reach in the future, huh?
Absolutely. But before we get too carried away with the possibilities, we need to remember there are still some pretty major hurdles to overcome.
Like what?
Well, we touched on it earlier, that density issue. It's a major roadblock. Our lungs, they're just not designed to handle liquids as easily as gases. Breathing perfluorocarbons, it's physically demanding, to say the least. And that's a challenge that scientists are really working hard to address.
So even though the concept is sound and the potential is huge, we're still limited by our own bodies.
Exactly, but never underestimate human ingenuity. Scientists, they're constantly working on ways to overcome this density dilemma, and we're already starting to see some really promising developments.
This is all so fascinating. It's like we've only just scratched the surface here. Can we dive a little deeper into these challenges and potential solutions?
Absolutely, there's so much more to explore. The research into less dense perfluorocarbons, the development of assistive breathing technologies, it's all happening.
Perfect. Let's take a quick break, and then we'll come back and continue our deep dive into the fascinating world of liquid breathing.
Welcome back to our deep dive into liquid breathing.
So in part one, we talked about the basics of liquid breathing and how it could change things like diving and medicine. But now I want to really dig into some real-world examples. Like, how is this technology actually being used today?
Well, like we said, liquid ventilation is already showing amazing potential, especially in medicine.
Okay.
It could be used to treat lung conditions that, in the past we thought were untreatable.
Wow. That's incredible. So you're talking about healing lungs that are like severely damaged.
Yeah, exactly.
How does that even work?
Well, let's say someone has really bad burns, right?
Okay.
Their lungs, they're often affected by smoke inhalation or, even direct heat
Oh,
damage.
wow, yeah.
Liquid ventilation, in these cases, it can be a lifesaver.
So the liquid breathing, it basically protects the lungs from getting worse.
Exactly. The perfluorocarbon liquid, it forms a kind of protective barrier inside the lungs,
Okay.
so it keeps harmful stuff out and it reduces inflammation. This gives the lungs a chance to heal.
So it's not just about treating, like, the burns you can see on the skin, but also the damage to the lungs that you can't see.
That's a great point. It's like a more complete approach to treating an injury, right?
Right. Now, I've also heard about liquid breathing being used in space exploration.
Oh, yeah, space. That's a really fascinating area.
I mean, it sounds like science fiction, but people are actually talking about it.
Oh, absolutely. Liquid breathing could be crucial for astronauts, helping them deal with, the extreme conditions of space.
Okay, but I have to ask, how exactly would breathing liquid help astronauts?
Well, think about the challenges of space travel. Microgravity, radiation, the intense pressure changes.
Yeah, space is no joke.
Definitely not. But liquid breathing could help with some of those risks. For example, in microgravity, our bodily fluids kind of float upwards,
Right.
and that puts pressure on the heart and lungs. But if an astronaut is breathing a dense liquid, well, it could help counteract that fluid shift.
Interesting. So it's like creating like artificial gravity inside the body.
Yeah, you could say that. And then there's radiation. Space is full of harmful cosmic rays that can damage DNA.
Right. That's bad.
But perfluorocarbons, they're pretty resistant to radiation.
Okay.
So they could act like a shield for the lungs.
Protecting them from those harmful rays.
Exactly. And this is especially important for long space missions, like to Mars.
Yeah, because astronauts would be exposed to way more radiation, right?
Right. It's pretty amazing to think that something as simple as the liquid we breathe could have such a big impact on space travel.
It really is. But let's be real. We're not going to be sending astronauts to Mars in like liquid suits anytime soon, right?
Probably not. We've made progress, but there's still a long way to go. The logistics alone are a huge challenge.
Like, what do you mean by logistics?
Well, think about the weight of the liquid, the equipment needed to keep it at the right temperature, and the training astronauts would need.
Yeah, that sounds pretty complicated.
It definitely is. But remember, we've only been researching liquid breathing for like a few decades. Who knows what we'll be able to do in 50 per 100 years?
That's true. I guess when it comes to space exploration, patience is key.
Absolutely. And even if we never send astronauts to Mars in liquid suits, the research we're doing here on Earth has the potential to change things in medicine, rescue operations, so many fields.
That's a good point. Sometimes the most out there ideas can lead to some really incredible discoveries.
That's the beauty of science. It pushes the boundaries of what we think is possible.
Now, in part one, we asked our listeners, if you could safely breathe underwater, where would you go? I've been thinking about that.
Oh, interesting. Where would you go?
I don't think I'd go for the deepest parts of the ocean, like you.
Okay.
I think I'd explore coral reefs. Imagine, like, swimming through those vibrant ecosystems, seeing all the marine life up close without disturbing them.
Wow, that's a great choice. It shows how this technology could be used not just for exploring, but also for, conservation and research.
Yeah, exactly. It's about understanding and appreciating the natural world in a whole new way.
And speaking of understanding, there's another aspect of liquid breathing that we haven't really talked about, the psychological impact.
Oh, that's interesting.
Think about it. Breathing is such a basic part of being human. We do it without even thinking.
Right.
But switching from air to liquid, that's a huge change mentally.
So, like, scientists are studying how that affects us.
Yeah, absolutely. How it affects our mental state, how we see the world, even our dreams.
Wow, so there's a whole new field of psychology developing around liquid breathing.
You could say that. It's fascinating to think that this technology could change not just our bodies, but also our minds.
It's like we're diving into a whole new world of possibilities, both physically and mentally. What else is there to discover about liquid breathing?
Well, in our final part, we'll explore some of the more speculative possibilities for the future of liquid breathing and talk about the ethical side of this technology.
Sounds like we've got a lot more ground to cover. I can't wait. So we've been on this incredible journey exploring liquid breathing.
Yeah, it's been quite the deep dive, hasn't it?
We've talked about the science, the potential application. I mean, everything from deep sea diving to space travel.
Yeah.
But there's one big thing we haven't really touched on yet.
What's that?
The ethics. Anytime you have a technology that's this powerful, this transformative, you have to think about the bigger picture.
Oh, absolutely. Liquid breathing, it definitely raises some serious ethical questions.
Yeah. Like, for example, accessibility.
Right.
If this technology takes off, who gets to use it? Will it be available to everyone? Or will it just be another thing that only the rich and powerful can afford?
It's a valid concern. We've seen this happen with other technologies. It's important to make sure that these advancements benefit all of humanity, not just a select few.
And what about the military? I mean, this technology could be a game changer for underwater warfare.
That's right. While liquid breathing could be amazing for rescue missions, it's not hard to imagine it being used for, well, less noble purposes.
So how do we prevent that? How do we make sure this technology doesn't fall into the wrong hands?
That's the million-dollar question. It's something that scientists, policymakers, and really all of us need to think about very carefully. We need to find a way to balance innovation with responsibility.
Okay, but let's have a little fun for a second. Let's imagine that liquid breathing does become, a normal thing. What could the future look like?
Oh, that's fun. Imagine a world where anyone can explore the ocean depths. Like underwater theme parks where you can swim with all sorts of marine life, no scoop gear required.
That would be amazing. Or, like underwater gyms, you could work out in zero gravity.
Exactly. And the medical applications, think about that. If liquid ventilation can protect our lungs and maybe even slow down aging, who knows how long we could live?
It's mind-blowing to think about. This topic really pushes you to imagine things that seem like they're straight out of science fiction.
It does, but even if those futuristic scenarios never actually happen, the research is already helping people today.
That's true. So as we wrap up our deep dive into liquid breathing, I think it's safe to say that we've only scratched the surface.
There's still so much to learn and discover.
And to our listeners, I'd say, keep exploring, keep asking questions, and never lose that sense of wonder. You never know what amazing things are out there waiting to be discovered. Maybe someday we'll all be breathing underwater, exploring the oceans, or even venturing into space thanks to this incredible technology. Thanks for joining us.